Uh, so this is for the assignment 27 for Tech 1. Look like a student was asking for help how to draw that schematic. Okay, so let me go ahead and open up PSpice and then I can share the share screen. This screen. Okay, so this is the what we need to do is so PSpice. Okay, so as you can see, I did sort of put the this part is called bubble. Okay, so therefore you want to do is just come in. So open up your PSpice, goes into draw, and go to get part, and then you come and then come in here and just type in the part. Okay, so right up here, this is what we need bubble. So 1, 2, 3, 4 of those. So we're going to type in here bubble. Okay, so there is that symbol. Okay, and then you can place it here. So 1, 2, 3, 4 right now. And the next one is UA 741. So UA 741. And that's look like that symbol. And then go ahead and place it. Okay, so there's place. Okay, the next one is all the resistors. So 1, 2, 3 resistors. So 3
Four.
resistors. So R, 4.
One,
Uh,
two, three.
1,
One,
2,
two, three, four.
3. Oh, 4. Okay, you got it. Okay, thank you. Okay,
Yeah.
so the 1, 2, 3, 4. Okay, so next thing capacitor 1, 2, 2 capacitor. So C for capacitor, place. So 1, 2, and then we got VDC. We got 1, 2 of those. So VDC, place. 1, 2. Oops, close that. Okay, go edit. Get, okay, draw, get part, and then we're going to get the next part is going to be VAC. So we need VAC, VAC. Okay, so that looks like that symbol. So place. Okay, and then we have ground. 1, 2, 3, 4. Okay, there's 4 ground. Okay, so ground, GND. Okay, we need ground earth, earth, place, and close. Okay, so 1, 2, 3, 4. Okay, so first thing I want to do is well, just take a little, make a little bit bigger. Okay, so this one right here, look like pin 3 is on top, pin 2 is on the bottom. According to the schematic, we need pin 2 is on top and pin 3 must be on the bottom. Okay, so we had to flip this thing here. So highlight that to go here and then go to edit and then go to this one here. So to flip, okay. So now we don't have it in that form yet. Now we have to do just do a couple more rotating. Rotate one more time, and there it is. Now we have exactly like that symbol here. Number 2 is on top, 3 is number 2 pin is on top, number 3 pin is on the bottom. Okay. So and let me go ahead and put these move this label inside so I can have it. Okay, so now I have that in place. Now I have to do is just look at power supply. Number 1 is would be here, look like the positive is on top, and the other one look like the short side is on the bottom. So I can highlight that one, Control R to rotate it. Now I have exactly the 2 that I need according to the picture. Okay, so now I have to do resistor 1, resistor 2, resist. Okay, so resistor 3 and resistor 4 need to go vertical. Okay, number 3 is here, so Control R to put it, and then number 4 is right here, Control R. So now I have exactly in that uh, order. Okay, so now we have, okay, so now I just have to do just move this one around a little bit, so give me a little bit more room to work with. Okay, so just okay, so now I have to do move one of these bubble there. And this one, okay, so we need okay, we need 2 of them. That one of them is on top of this one. And then this one needs to go the other way. So rotate that. And we just pull it and then drag it and put it right there. Okay, so next thing we want to do is okay, so we want to do is just rearrange. So R2 need to go on top of this somewhere in this part, and C1 is going to be on top of that. So C1 capacitor 1, C1 here, move it somewhere here. And capacitor 2 is going to be right here. So capacitor 2, put it somewhere here. And resistor 1 should be after that. Okay, so right there. And resistor 3, it's going to be right after, look like in between, split in here. And then resistor 4, it should be at the output, the load. Okay, so the load is somewhere here. Okay, so, and then we need to move our supply in here. So put the supply over here and move our common to be underneath there somewhere. Look like one common's here. And then one common is going to be coming off from here. Okay. Okay, now we have to do is just move this one a little bit onto the side here. Okay, so this one here. So now we have the 2, move the common here, and move this one here. Okay, so now look like we have approximately where we need all the parts is at. Click on here to just maximize it on here. Okay, so now I have to do, before I do any of my connection, usually once I'm ready, I just ready to run the test. But I'm gonna go through and label it. So this one look like a negative on here. So therefore I double click on this here to, so first thing, put in red, double click it, and then you can change the label. So that is type in negative 12 volt. Okay, and that represents the negative side. So this one is a -1 right here. So we want to do just come down here and make that label according to that one. So that's reference to this one here. Okay, and the positive one would be this one on here. So we're going to be putting positive 12 volt. And then we come over to the positive here and make that label also 12 volt. Okay, now we have to do just change the value according to that. So this is positive 12, that's 12 volt, and this is also 12 volt. Okay, all right, so next thing we want to do, R1 is to be 47K, so R 47K. Okay, and then R3, 2.2K, 2.2K. And then C1 is 33.3 nanofarad, so 33.3 NF for nanofarad. And then the C1 is, C1, okay, I put C1 over here. Okay, let me go ahead and move that C2 on top and C1 down here. Okay. All right, C2 is going over there, and this one is going also 33.3 nanofarad. Okay, and then R1, R2 is 100K, 100K. And then R4 look like 1K, so we're good to go there. Okay, so everything is look like it's pretty labeled, and then now I have to do is just go to my VN and make that label before I do my connection. So according to this one is that instructions that for VAC, AC max is 3 volts. So therefore I come in here and double click on this component and click on the ones that AC MAG equals 0 volt. I want to change that to 3 volt. Okay, type in 3 there, click enter, or click on save attribute and click OK. And that's, oops, and now I can change the label there. So I can go in there and change the label. So that's VN. Okay, so look like I got all the parts is in, I got all of it labeled. Now I have to do is go through and connect my circuit. Okay, so go here. And so we're going to be connecting circuit from there, go to here, this one go to here, this one here, and see, let me see. C2 is going to be coming connected to our, so this one need to be connected here, and this one is coming here and coming down here, and look like R2 is look like after, so we're going to be here and coming down here, and then this one here look like it's coming out here and connected here. This one come here and come out here, and let me see, connected here. This one coming here, connect it here. This one here goes here, and this one goes here, and this one goes here, and connecting the negative 12 volt to represent your saturation. Okay, that's connected there, that to there, that to there, that to there, and it's there. Okay, so now that we have all the parts connected, now we have to do is just go through the next part of this to do a setup. Okay, look like a setup, look like right here, step 3, setup. So we want to do is go to analysis, setup, click on AC sweep button, which is one right here. So click on that. And next thing he said to, okay, the type, he wanted decade, so choose decade. And then the end frequency is 10 kilohertz. So right here, 10 kilohertz. 10 kilohertz. Okay, so that's 10, 10.00. That's okay. Just put 10. That's fine. And usually I usually set this one like 1K or up here. But you can do just the 10K like he show you here. But I usually like to know how far spread my my frequency is. So I just put 10K, 1K, and then my final will be 10K. So it should be total be 10 marking. Okay, click OK. Now that one is done. And now I have to do is just save this file. So save as, let me see, I'm going to save this on my temporary folder. Okay, so there's my temporary folder. And this one is going to be assignment 27. So assign 27. This one is band pass filter. So band pass filter. And you can name it whatever you want. And I just, just give you an example. This is for assignment 27, PSpice for band pass filter. So BPF. Okay, click on that to save. And that's done. Okay, now I can be able to ready to simulate. So now go up to analysis, simulate, and then we're just going to start collecting our data. Oops, you got us all that answer already. Okay. Let me see. Okay, so we'll come back over here. Oops, that one still have to answer too. Okay, let me go ahead and delete that, all that. Okay, so now we have, well, it's still passing. Okay, good. I'm still passing. Okay, now we have to do it just, now we have simulate. Now we want, oh, I don't think I would put the V in and V out. I did not put that label on my circuit. So I have to go back and type that in. So this is V in and out here, V out. Okay, now that's there. Now save one more time and go up to analysis, simulate. Okay, so now we have the simulation. We have to do is just put on a trace. I just used the graphical one right here. Click on that. Now we have to do is just filter out all these other one. We need is the voltage. So therefore this one is gone, gone, gone. And so the only one that we need is the V out. That's the information we need. Okay, so click on there and there is your band pass filter. Okay, so now I have to do is giving this one a little bit more room so it can see a little bit better. Okay, so now we have to do is just put on the cursor, use this one right here, turn on that. And then you look at where the band, so we want to look at the center frequency, which is the right up here. So you want to do is just click on this one right here, say max, cursor max. So click on this symbol here, and it will put you at the max point. At the max point, your center frequency is 329.610, and the voltage there is 3.1907. Okay, so now I have to do is just come in here. Okay, they said V out on my center frequency, which is right here. Type that in, 3.1907. Okay. And then what was my center frequency? It's at 329.61 hertz. So right here, my center frequency, 329.61.61. Okay. And so then after that, you just go ahead and go collect all your data. Okay, so let's see, the F at cutoff at F1. F1 would be equal to 0.707 times the max voltage, which will be at the center frequency, which is this one right here. So that gave us, and we had to look at the voltage at 2.26, and F2 would be also equal to that. So 7. Uh, so 0.707 times that value. Okay, so that there, and that's also had to be, so one side would be on the right, one side would be here on the left side, the other one would be on the right side. So one on left, one on right. Okay, so now we have to do is just go find that value where it's at 2.26 volts. So right now I need to move up here. So that's close to 2. Now I just use my arrow to move that up until I come into 2.26 right there. Okay. So that is my first cutoff. That is my F1, my lower cutoff frequency right here. Let me go ahead and enlarge that a little bit more so you can see easier. Sorry about that. Okay, so that would be my center frequency. So that would be F1. So F1 would be here. So that's giving me 280, 285.2, 285.2. You can type all that number if you want, not necessary. So that's close enough. And then now I have to do is just go to the other side. So the other side will be 2.2611. So I'm going to go to the other, go to all the way to the right side. I have to scroll back up. Let me see. Go to that 2.2611. Okay, matching there it is. Give me 380.17, or I'm going to say 380.1. Okay, 380.1 or point 0.2. It's up to you. I'm just using 0.1. All right. So that's the lower cutoff. Now you can do calculate the bandwidth. The bandwidth is equal to your F2, which is here, minus your F1, which is right up here. Okay, so you press enter, and so that's giving us approximately about 94.9 hertz. And calculate the quality of your circuit. Uh, so you look at this one, is it F center divided by bandwidth. So therefore is equal to your center frequency, which is right here. It's in hertz, and divided by your bandwidth, which is down here, which is in, so if I'm looking at my Excel, so it's going to be B71. Okay, so divided by B71. Press enter, and there it is. So that's giving you all that. And then you have to do just do all your calculation here. And what is our VN? VN, according to this one, is 3 volts. So we're going to use that 3 volt to do that calculation. So you're going to use this one, so you're going to take this value, which is the V out, divided by your VN, divided by 3, the 3 volt. Okay. And so on all this. And then you do change it to, and then do your calculation for decibel. Okay, so on top part here, you're gonna be doing the same thing. You have to collect your data. So first thing you want to do is go to 30 hertz. So 30 hertz would be right over here. And so that's 29. So right there, so 29, 30. So either right here or this, look like this one is the closest one to 30. Okay, so 29. So that's 84.765 millivolt. So we have to convert that to volt. So have to convert to that. So therefore, it's going to be 0.084. Looking to use another digit. So I'm going 848. Okay, 848. That's going to be good enough. Okay, so next one you just do the same thing. Okay, so you just have to do just move your cursor to the next point, and we need to get to 100. So this one look like that one about 4. This one is about 2.2 off. So this one about 0.4. That's what this one way too far. This one is the closest one. So this one here is giving us 308.604. So that's in millivolt, and we need to convert it to volt. So therefore, it's 0.308, 308 let me see, 3085, 6. Okay, so, and then once you do, just like I said, just go through and just collect all your data and then do your calculations. So therefore, this one is going to be V out divided by V in. So this one here divided by 3 volt. Now that was what we put as an input. And then you do the same thing with this one here and do all the other one to get your gain. And then once you're done with that, then you calculate your output. So therefore, your dB. So that's equal 20 times log open parenthesis. It will be of this gain and close parenthesis and press enter, and that's give you the value. Okay. So that's pretty much it. So I'm going to let you do finish out the rest of the table. So that way we can move on to anybody else that has any other question. Okay, so all right, so I'm going to stop sharing. Okay, does anybody have any other question? Okay, let's see. You want to ask about pin 4 and pin 7 is opposite. Thanks. Okay, yeah, you did. You saw what I did right minute ago with this here. Okay, let me go back to sharing that. Okay, like you were seeing this U here. So like I said, when I was draw here, and when I type in the UA, so that is the symbol. Like I said, I'm going to just put it somewhere here, for example. Okay, so from here, as you can see, it doesn't match like that you saw on the schematic. It doesn't match up here. So you see that pin 3 is up here, pin 2 is up here, so, and then pin 7 is supposed to be on the bottom. So you have to do it. Just make sure you highlight it and go to edit and click on flip. Okay, or you can use your keyboard Control F would flip it. Let me see. Okay, so Control flip. Okay, look like it got still schematic running, so I have to close that one first. Okay, come back in here, edit, and then goes flip. Let me see why it's giving me. Okay, why is okay, I guess because it has the same one. Okay, so let me see, delete that one for now. Okay, so let me say delete all these wires so I can do that one more time. Okay, so if I take this one out for now so I can use it somewhere here. Okay. Let me see, open up somewhere over here. So you can see, okay, so I'm going to put it the way that it was before. So if I can go ahead and delete this one out the way. Okay, so now I just have to do, just put the one. Okay, so originally is like this. Okay, when you originally put in, it will be something like this. So you want to get pin 2 on top and pin 3 on the bottom. So therefore you want to do is go in here, go to edit, go to flip. Okay, now it's flipped. Now it's on the other side, and then you do control, do couple rotate. Okay, couple rotate. Now you have exactly pin 2 on the top, pin 3 on the bottom. Okay, so that's how you flip that until it matches the Excel. And then once you have that into Excel, now you can pull that back and then put it into your circuit. Okay, and then do your connection. Okay, let me see what next chat. Let me go stop sharing so I can go read the chat. Sorry about that. Okay, okay, so having problem with my laptop. Okay. Okay, look like all right. So did I answer your question on that, on how to do the on this P-Spice for assignment 27? Okay, looks good. Okay, anybody else have any other question?
Thank you.
You're welcome.
Thank
Okay.
you.
You're welcome. Okay. Very good. Okay. Well, back to Mr. Pham for class.
Thank you, Sean.
You're welcome. Thank you.
Okay. Yesterday we already talking about the Jfet. Okay, we'll be continuing on that. Jfet will be affect the field effect transistor. Okay, and they will be using for amplifier switching devices, impedance matching. The difference between the bipolar and the Jfet a FET, a voltage controller device. Okay, why the bipolar get a current control device? FETs also have a higher input impedance, but bipolar have a high gain. FET are less sensitive to temperature variation and more easily integrate on IC. FETs also general more static sensitive than the bipolar. Okay, that one we already done it. Okay, and this thing here, you must remember. What is the VP? Pin up voltage. What is it?
That's the voltage at which the current ID becomes constant.
Exactly.
Yeah.
That means at that voltage, the current will be constant, and that will be equal ID at X. And what is the ID at X?
It's the maximum value of the drain current,
Not done.
where VGS equals 0.
Exactly. Okay. ID at X, that is your maximum current at VGS equals 0. VGS will be shorted. Okay. And normally they given to you ID at X in the data sheet. And also we can talking about a VGS up. Okay. At the VGS up, what the ID equal?
0.
ID equals 0. Okay. Same thing. At the ID at VGS up will be equal to 0. The relation between VGS up and the VP. VGS up and the
Yeah,
VP
equal
all
but
time
opposite.
equal the value. However, they must be opposite. Okay? And this is a summary for everything you need. Try to read over and over. Okay? The maximum drain current out of Jfet occurs when the gate source voltage is 0. The drain current is not constant in the region between VP and the VDS maximum. If the drain voltage too large, Jfet will be breakdown. Jfet acts like current source when it operating along the almost horizontal part of the drain curve between the VP and the maximum VDS maximum. The minimum voltage of VP equal a pin off voltage. The maximum voltage VDS maximum will be called a breakdown of voltage. Okay? Between the pin off and the breakdown, the Jfet acts like the current source with the value of the ID at S. Again, ID at S stands for current from the drain to the source with the source gate. That means VGS equals 0. Also, Jfet can be a resistor. So that's why you can see the ohmic region. The value of VGS that makes the ID approximately 0 is the cutoff voltage. VGS up. The FET must be operate between VGS equal 0 and VGS up. Okay? Comparison, upping up and a cutoff. VP is the value of VGS at which the drain current become constant, and it always measure at VGS equal 0. VGS up and VP are always equal in magnitude, but opposite in size. A data sheet usually given either VGS up or VP, but not both. You know one, you know the other. Okay? On this display here, very clear for you. Okay? This is the IDSS. Okay? And the vary between VGS from -4, -3, -2. That will be given to you the value of the ID. Okay? So that's why we can set the Jfet in a voltage controller. They control by VGS. Okay? Now, if you're looking on this display here, they're just telling you, you get the VGS up here, okay? And you get the no current. That only telling you the channel between the drain and to the source will be open, no current, okay? So make sure you understand at the cutoff, voltage ID will be equal 0. And the VGS will be equal VGS up. Okay? That's just telling you the difference between a P channel and an N channel. Okay? On the N channel, VGG have to be negative and VD will be positive. However, on the P channel, then the VGG have to be positive and the VDD will be negative. That's only the difference. Okay, this one we already calculated. And now, on this thing here, okay, Jfet transfer characteristic curve for N channel. So basically, this stands for ID, and this stands for VGS. Okay, at the IDSS, VGS equals 0. You get a 1 point. And at the VGS of ID equals 0, you get a second point. And when you draw that one, that's what the transfer. Okay, they say ID 0 when VGS equals VGS up. Okay, ID equals IDSS when VGS equals 0. Okay, so now in this one, they can display both sides, one for the transfer and the other one for VGS. That means at any point on the VGS, for example, VGS equals -1 volt, then you can say, you can get the current ID equal, okay, maybe 1.8, 0.8 or whatever number here. And you want the VGS to going down, they will be -1, okay? But for you, only thing is this is the formula we'll be using to calculate the ID. ID equal IDSS times 1 minus VGS over VGS off square, okay? That we'll be using all the time. This example already done. Okay, now another thing you need to memorize. Okay, forward train conductor. For transfer conductor, GM is the change in the drain current for the given chain in the VGS. Okay, so basically you can see the definition. GM chu you take I delta I d chu detail divide chu delta VGS. That means you can take the different, but different, the definition is not important. Okay, the important will be the formula here. GM equal GM0 times 1 minus VGS divide VGS off. Okay, where GM0, what is GM0? The definition. GM0 means that is a train conductance at the VGS equals 0. And normally they given to you in the data book. Okay, if you get a question, just go ahead and ask. I can answer you. To me, you don't need to chat. The thing I have no time to read it. Go ahead and asking. Any question up to this point?
Can you explain what is forward transconductance? Transfer conductance GM. I mean, what is GM physically?
That's a train conductance. That means this is the curve for what? Okay. When you get the IDSS and you get the VGS off, you get the curve. That is the equation for the equation ID equal IDSS time. Okay, 1 minus VGS over VGS off square. Okay, so that is the equation. Okay, and GM in here, they just define as the transfer conductance. Okay, that's only thing I can say.
Is it a resistance or what?
Opposite to resistance. They will
Okay,
be unit of,
that is a conductance.
you see, unit of PM is soluble. F. Okay, they're not resistant.
It's a reciprocal of resistance. That is a conductance. Am I
Right.
correct?
Exactly. Conduct.
Thank you.
That's what they say, conductor. Okay. Data set normally given GM0. And you can calculate GM by using GM0. And also you can calculate the GM0 if they not given to you. Equal to time IDSS divide absolute value of VGS off. Okay, now let's see. The following is included on the data sheet. Okay, they given to you IDSS is 3 milliamp. VGS off is minus 6. And GM0, 5,000 micro Siemens. They using this value to calculate GM and the value of the ID at this point. Go ahead and calculate, telling me is it you get what you get.
What is YM0?
That's just GM0.
Oh, it's GM0. Okay.
Okay, I already get the formula for you. GM equal GM0 times 1 minus VGS divide VGS off. Do the calculation, tell me what you get GM.
We're doing the calculation for the problem on the bottom that's just drawn out for us.
No,
What-
you're doing a calculation for number A.
Hey, Mr. Pham, that's really GMO where you got YMO equal 5,000, correct?
Right.
Okay.
That normally on the data sheet, they will put in a GYM0. But that basically that's GM0.
Yeah. That, YM is that's just a typo, right?
Right,
It's supposed to be GM0.
right.
Okay.
Is the answer of GM 50? Is the answer of GM part A is 50?
Can you tell me the answer for your calculation?
I got GM as 50.
Maybe not.
Is a micro Siemens?
Micro Simon.
Okay, so then it should be, let me check it one more time.
Okay.
I got 6.671 microsimon.
You
Try
say
again.
you get 6.
0.671.
Try again.
Try again.
I got 167 micro. Wait.
How come quite different on why? I don't know.
Yeah, I got 166.
Yeah, 166.7 micro.
Yeah, me too also got the same one.
I get a 1667.
One 667.
Yeah,
Yes,
16,
sir. I also
1666.7.
0.001666 is what I got.
Now
Seems
I
like
want Michael.
The one Mr. Pham got seemed like it's right.
Yes, in micro, that's right. 1667. Yes, or at least that's what I got.
That is the answer.
Oh, it's -6. VGR. It's -6.
Yeah, because what you got is VGS is -4 and VGS off is -6. So a -4 divided by a -6 divided by a minus is a plus. So it'll be 1.
Then I got 133
1 minus that, yeah.
microamps for ID.
Yeah. So yeah, Mr. Pham, I think
Oops,
yours
they
is right.
squared again.
Hey, Mr. Pham, everybody else is 50-50, but you're right.
Okay, what I did.
333 microamps.
Fight. You're doing good job.
Thank you, sir.
Three,
Perfect.
Are you daddy's love?
3.
Oh my God, your daddy's love?
I'm also doing a good job.
Everyone is doing a really good job, I think.
I already given you the formula. You cannot get the right answer. It's a problem.
We don't know how to use a calculator. We do it mentally, that's why.
Yeah, everyone doing a very good job. That make me happy.
Potlucks make me happy.
Okay, another example, just for you to look into it, I don't care. If you want to calculate the input resistance, they can using VGS divide IG at that, okay? You can look into that, we don't care. Now, there's another measure here. DC bias, like the bipolar, they need a bias, okay, and to make the NPN, PNP transistor working before they can able to do a amplifier. Same thing, Jfet doing the same thing, they need the DC bias. So many techniques can be used to bias the Jfets. In one case, okay, in one case, the gate source junction reverse bias, okay. Most common bias technique is the gate bias or the fixed bias. The second one will be the cell bias. The next one voltage divider bias. That's what we will be go through. We not pay attention on the current short bias. Okay, now.
Ooh. Actually,
Okay, now figure A, B, and C. That for the fixed bias. Oh, that one is for the fixed bias. So when you're looking into the Jfet, you have to recognize, is it a fixed bias or cell bias or voltage divider bias? Okay, right now we're talking about fixed bias. The first one, this is VG, VS, and VD. And this is a negative voltage, okay? And this is a positive voltage. So I set this to be minus 3 volts. My question is, what VG equal? That one 1 mega ohm.
E equals 0.
Okay, well, what VG equal?
Minus 3 volt.
50-50. Now, this is the current flow here. What that current supposed to be?
The gate current.
Yeah, but what's it supposed to be?
It should be 0.
They're supposed to be 0.
Yeah, because that 1 meg resistance make it hard for current to flow.
Right. That means resistance should be. Okay, if the resistance is 0,
The
current
voltage
is
is
0.
0.
Current is 0.
Right, then the
voltage
voltage
drop
is 0.
here. The voltage drop across that resistor will be 0.
0.
That will be telling you VG will be equal minus 3 volt. You get that? I can do without it one. I can connect directly here. Same thing. Okay? You can connect directly minus 3 volt to the to the gate.
So,
However,
Mr. Pham, just
Yeah.
real quickly. So, are you saying that the resistor is so big, the current is zero, so it's almost like the resistor is not there and it's just directly connected to the -3?
right, you can do it by connect directly to the gate from -3. Okay,
Okay.
but I try to explain to you why do they need that resistor, even they're not doing anything. Okay, I can tell you. This is for the AC circuit. That means for the amplifier. When you get the amplifier sideways applied to the gate, and the capacitor, that will be a blocking DC AC coupling. On the other side of the capacitor, you get a sideway. However, you understand when you're converting circuitry from DC to AC, and the on of the DC power must be shorted. That means from that one for AC, okay, they must be shorted to ground. So now, if you don't have a this resistor, so sideway will be short to the ground, okay? So they cannot be working. So that's why they need that resistor. Even they're not doing anything. But for the AC, you must get that resistor. If you don't have a that resistor, you cannot get any sideway. Go to the gate of the Jfet.
Can I ask you a question, Mr. Pham?
Go ahead.
So all this time I was in my head, I was thinking capacitor allows AC and resistor either blocks the AC
No,
or changes the phase shift, but it's not true. It does allow AC with the same resistance, doesn't it?
no. They only blocking DC and a coupling AC. They allow AC to pass. Resistor nothing to do with that.
Okay, thank you.
Yeah, resistor nothing to do. However,
Now it makes more sense.
however, on this configuration, they must get the RGG. That means resistor at a 1 mega ohm. The thing is, without that resistor, when you can converting DC to AC, then sideway will be short to the ground. Okay, when you get that resistor, that means the sideway cannot short to the ground. Then they can be go to the gate. That is what they try to explain to you in here. Okay, if RG were omitted, no AC signal would appear at the gate because VGG is at around for the AC.
Wow, she looks like Kiwi.
He's so pretty.
Mr. Van, can you mute everybody?
Yeah. Go ahead.
Is this both circuits a fixed bias? Hello.
Well, now what do you mean?
So the left-hand side circuit, the JFET and the right side of JFET, both are fixed bias. We are right now talking about a fixed bias. Am I right?
What are you talking about?
So the biasing is.
If you get a question in this circuitry, then I can answer you.
No. My question is about the same circuits. One, the first left-hand side JFET is a fixed bias, and the right side, the JFET with the sine wave is also a fixed bias. So right now we are talking about a fixed bias. Am I right?
Right.
Okay, thank you.
Fixed bias means at the base. No, at the gate, they get a negative voltage. You see?
Can you write fix next to it, Mr. Pham, so we will know? Just write fix, F-I-X next to it.
Yeah, when you get the negative voltage applied to the gate, that will be fixed bias.
Thank you.
Okay? And now, let's see. On this circuitry is a fixed bias. VDD 12 volt. VGG minus 2 volt. Okay? For the circuit so they want to know VGS Q. What that mean?
VGS at the center frequency?
No.
I
What
don't
that
know.
mean Q?
The Q point of VGS.
Q point. Okay? That is a Q point. I can go back quickly here, try to explain to you again. Make sure everyone understands. Okay, that means any point, okay, in here, that's what they call a Q point. Okay, you can get the IDSS and you get the IDSS equal 0 here. Any point on the curve, that will be Q point. Now, they given to you IDSS 5 milliamp, ID VGS of minus 4 volt. Okay, and they want to calculate the VGS Q, IDQ, VDS, VS, VD. On this one, easy to get a VS. What VS equal?
Zero, it's attached to ground.
Yes. Right?
Mm-hmm.
Okay.
Okay.
And now you need to calculate the ID. Okay. So what the VGS? Number A. Okay, I can help you. VGS equal what by basic definition? What VGS equal?
Oh, you mean like, wait a minute.
Gate to source voltage.
Right, but I want the basic definition for VGS.
VG minus VS.
That's what I wanted. I don't need to see on the circuitry, I still know. VG. Right?
Right.
Yes, sir.
Okay, what VS equal?
Zero.
That equal 0. So equal VG.
Mhm.
Okay? And the VG will be equal minus 2. So VGS equal minus 2 volt. Okay? That means the voltage here and the voltage here the same. So after you get the VGS, you want to calculate the ID using this formula here. Calculate, tell me what you get.
125 microvolts? That can't be right. I'm sorry, 1.25 millivolts.
Come on, I want to calculate the ID, right?
Mr. Fan, I'm a little bit lost.
Okay, what you
Okay.
like?
VGS equal VG minus VS, and since VS is equal to 0, it's equal to VG then, okay?
Right.
I follow that.
Right.
But then how do we get V, I mean, is VG equal to minus 2 volt?
I just explained to you guys, right? I said the current cannot flow through the 220K. Okay?
Mm-hmm.
So look like no voltage will be dropped
Okay.
through the RGG. So whatever voltage on this side and the other side will be the same.
Okay, but I thought that only occur when we have a very high resistance, like 1 meg or.
Right. Now that 220K, that's enough.
That's enough? Okay. All right, thank you.
It's not 1.25 volts? Yeah, that's 1.25.
Perfect.
Thank you. Good job, Catherine.
Make sure it's milliamp,
Thank
Yeah.
you too.
not millivolt.
ID
My
Unit
bad on that.
conversion.
25, right?
Yes, sir.
Milliamp, not volt. Okay? Milliamp, not volt.
Oh, thank you. Sorry about that. You're right.
Okay. Okay, now you need to get the VD. And you know the VD formula. Okay? I read that one. Okay, VDD minus
IDRD.
time RD. Just tell me what you get.
Negative 4.75.
How come you get negative?
It's got to be
9 point,
positive.
yeah,
Oh, I'm sorry.
9.75.
What you get?
It's 9.25 volt.
9.25 volt?
What the value?
Sam gave you a thumbs up, so it's 9.25.
Correct. The right answer, 9.25 volt. That's easy. Okay? You done?
Done.
Now, one thing, make sure you remember. This is the current ID, right?
Right.
This is the current IS. That means the source current and the drain current. All the time for Jfet, ID equal
Equal.
IF. Make sure you understand that all the time.
Hey, Mr. Pham, so for the JFET and the bipolar transistor, they have many characteristics that are the same, such as ID equal IS and IE equal
I see.
IC in the bipolar.
However, bipolar and minor different, except the IB too small. Then they can say IB, IC, IE the same.
Mm-hmm.
Most of the time, they not quite too small. Then they not the same.
That's in the bipolar, right?
Right, it's bipolar. However,
But for the JFET, it's a little teeny bit difference.
yeah, no, they don't have a difference. They must be the same.
Okay, all right. Thank you.
Yeah, that's what I bring it up. Now you do for me.
One question, I'm sorry.
Yeah.
Regarding BDD, I understand how you get the 9.25 volts, but I don't understand why it is not negative.
VDD?
BD, you have, yeah, BD is equal to BDD minus ID times RD.
Right.
ID times RD give us a smaller number than BDD.
No.
So
No. RD equal 2.2K. Right?
yeah, RD 2.2K.
Time 1.25 milli.
Hey, Marcella, look at the chat.
I had it wrong at first too, but it totally works out. Check the math.
Right.
Yeah, just look at the chat there.
Okay.
Yeah, that current times that RD gives you a value, and you take that value from VDD, and that's how you get the answer.
Yeah, basically you're using the 1.25 milli times 2.2. Okay, got it. I guess.
Right.
Yeah.
And from that answer, you subtract it from 12 volts, and that's how you get the 9.25.
Okay. Thank you.
Okay, you guys do for me there.
50-50.
Okay, make sure VGS off equal minus 8 volt. On this one, the textbook, they need to draw. Now I get a question here to ask who understand. I said on this one, they get it wrong. VP support, if they're using VP.
I know, I think you just, Mr. Pham, I think what you're saying, the pinch off voltage should be positive, not negative. And then it should be equal to VGS off. So it should be plus 8 volts for the pinch off and minus 8 volts for the VGS off.
Yeah, now you get much better.
Right, exactly. It should not be a minus voltage. It should be a plus voltage.
Okay. However, I already gave it to you. I did that 10 milliamp VGS off equal 8 volt.
Right.
So now they get to calculate a VG. What VG equal?
Negative 8 volts.
Perfect. And what is VS?
0 volts.
Yeah, you don't know. You go back to next semester, take one.
Negative 8 and 0.
VG equal V minus 8 volt. VS connect to ground, they equal 0. And now calculate the VGSQ. I already telling you VGS equal VG minus VS, and that one equal VG, and that will be equal minus 8 volt. Okay, who get the ID?
I got 0 when I did it. I'm not. I must be wrong.
The formula calculate ID will be IDSS times 1 minus VGS over VGS off square.
I am also getting 0.
Because
VGS
isn't
is
it 1 minus -8 divided by -8, which is 1? So 1 minus 1 is 0. And then
Yeah.
no matter what you multiply it by, it becomes 0.
Okay,
Yeah, the same thing. I got it.
IDSS 1 VG over VGS off at square. So basically, you can get 1 minus, you get a minus 8 over minus 8, right?
Yes, sir.
Okay. So that one is minus and 1 and you get the 0, right?
Yes, sir.
Yes.
So ID equals 0.
Yes, sir.
Yeah, that is a problem from the book draw. That's okay.
Should that not be the answer?
ID 0. If you want, then we have to check. But that's
Yeah,
okay.
that should be the answer.
That's okay. No big deal. ID equals 0. So what the VD?
$16 volts.
Perfect. I think I know voltage drop across the 2K.
Since the current is 0, it should be 16.
Equals 60 volt.
That's correct.
VDS will be equal
16 volts.
16 volt. Correct. VDS equal VD minus VS. Okay. So look like you guys understand how to working with the fixed bias. Okay, now cell bias. Now, when you say what the difference between fixed bias and a cell bias,
You only have that VDD. You only have one voltage source.
right? They get only one voltage VDD.
You don't have a source in the gate.
Yeah, you don't have any voltage at the gate. They sort it around, right?
Right.
So basically, you will be saying, in order to solving for this cell bias, they must be given to you the drain conductor. That means the graphic right here. They must be given that. Without that thing, you cannot, very hard to solve. Okay, now, VG, you say they equal 0. The thing is short to the route. So that's why they say Jfet is the on divide.
Can you repeat the statement? Jfet is called which device?
A on.
Does that, hey, Mr. Pham, does that, are you saying the JFET is always on?
Right.
Okay.
A on divide. I will explain to you why they is on divide.
Hey, Mr. Pham, I just want to ask a question. I don't want to beat up on an old subject, but if a JFET is always on for the bipolar, is it always off or what is it?
Off divide.
So
bipolar is the off divide.
Okay, so bipolar's off and JFET on.
Right.
Okay, thank you.
The reason they bipolar, if you don't get a V at the base, transistor not working. Okay? That's why they said bipolar is the off divide.
Yeah, I'm just trying to relate both of them because you're dealing with two transistors, so it's good to be able to relate one to the other.
Right. However, on the JFET, even the gate is 0, they still working. So that's why they call it on divide.
Okay.
Okay, now what the VGS equal?
I have a question.
Yeah.
So the fixed bias is also on device. JFET fixed bias is also
now,
on device.
General. It's general. They are
General.
Right.
Okay. Yeah,
Fixed
got it.
bias,
Thank you.
that's only another way to apply the bias to the JFET. But all the time they will be on divide. Why? The thing is when they get a VG equal 0, they still working. They don't need any power at the gate. But bipolar, different. Bipolar, if you don't have a voltage at the base, they're not working. So bipolar is an off divide. That's why I explain to you the difference between on divide and the off divide. Okay? And now VGF. You already know VG minus VF. Is correct?
Yes, sir.
Yes, sir.
Okay, what VF equal?
-10.
Now, looking into the circuitry, this is the current ID here. And this also current ID. So what the Vs equal? Vs means
It's ID
voltage.
times RS.
Right. The voltage measured from the source to the ground. They will be equal ID times R. Correct?
Correct.
Okay. And then I need to erase that thing. Okay. Okay. Then VGS now equal VG. VG equal 0, right?
Right. You got minus there, Mr. Pham. You meant
ID.
oh, 0.
That VGS. Okay. Finally, VGS equal minus ID time. Okay.
Yeah.
To get up to the point VGS equal minus ID times RS. You get to that point?
Yes.
Okay. Now, if you want to calculate ID, and the formula will be ID IDSS times 1 minus VGS over VGS of square. Okay? What they want you to substitute this value into VGS right here. Okay? That means I minus ID times IS. So now you get involved into the equation. On this side, you get unknown ID. On the other side, you also get ID. So cannot solve it. Very, very hard. Difficult to solving this equation. Okay? So they don't want you doing calculation. So that's why they want to give to you the graphic way to make more easier.
So, Mr. Pham, basically, in short, you're saying for the self-bias circuit, the best way to solve it is graphically, not calculating.
Right, you cannot make calculation.
All right.
When you substitute the VGS into the curve, the formula ID equal IDSS 1 minus VGS over VGS of square. And you get both sides, you get unknown ID. That is hard to set to doing calculation. Okay, so they need the graphic. Now, I will be show you how can we do. I need the rule. Okay, so you get the VGS equal minus ID times RS. So basically, they want to get any line, okay? Any line okay. You can draw any line. For example, this line here. When they cut the curve at the point right here, Q point, you can calculate ID by this way. That ID. You can calculate the VGF this way. Okay. So basically, you need to draw the line in order to cut the curve at the Q point. Now, in order for sell buyer, first thing, I need point A. Okay. And the point A I set ID equal 0. Then what the
You have
ID
VGS off.
VGS,
VGS off.
VGS equal what?
0.
Now right here. On this formula here.
VGS is off, not 0.
We're not talking about VGS off. We're talking about the equation. VGS equal minus ID times RS. If ID 0, then what VGS equal?
That is also 0.
Yeah, that's what I said right here. I already gave it to you right here, right?
Right.
Yes.
So the first point I wanted is this point right here. Point A. Okay.
So when you pick point A, you pick point A to be ID equals 0 and VGS off. I mean
No,
VGS, not VGS off, VGS to be 0.
Right. From this equation right here.
I think I understand now. And so it's going to be point B that's actually on the curve, and you draw the line.
Yeah.
Okay.
Now, okay, not yet. I get another point B. Okay, you can set ID equal any value from 0 to ID at F.
Oh, that's along the y-axis then.
Right. Point B, you can get any value, okay, from 0 up to IDSS. IDSS is 10 milliamp, okay? So you can say ID equal 5 milliamp. That be fine to me. You can set ID equal 2 milliamp. Or I can say ID equal 10 milliamp. Okay. So if ID, let's see, if ID equal 10 milliamp, then you go back to the equation. You get what VGS.
VGS is 0 at 10 milliamps.
Now you have to substitute into this for the equation.
Negative 10 RS?
So that will be minus 10, right?
Yes, RS.
RS equal to 100 ohm. That means 0.2, right? Kilo ohm. The thing is, you multiply milliamp with the resistance. Then you don't have to converting, then you have to converting resistor to kilo ohm. They're telling you, you get VGS equal minus 2. Is it right?
Yes.
Okay. Then you can get minus 2 somehow in here. We don't care. I just telling you how to draw. That's what you get minus 2. Okay. So you can get IDSS. That's the second point. You go this way. And you go from here, go up to here. This is the second point B. Okay. And now you're typing A to B. Whatever they cut here, that will be Q. You want ID, go this way. You want VGS, you going down. Okay, so now for this cell buyer, okay, you have to draw July.
Hey,
Here.
put that back, Mr. Pham.
Right,
Hold
here.
on for a minute.
I already gave it to you here. Okay, if you want to get this thing.
Just a second, just a second.
Yeah, that's okay.
All right, got it.
In here.
Mr. Smith, you took a screenshot.
Now, on this circuitry here, one of the most common way bias Jfet is a cell bias. Only a single power supply is yield the drain supply voltage VDD. Okay, so now you're looking in here, they already given to you. First thing, you need to get 1 point A. Okay, and the point A, normally you pick right here. Okay, and the second point, you can pick ID equal 2.5 or ID equal 5 or ID equal 7.5 or 10 milliamp. However, the equation, you get VGS equal minus ID time RF. Okay? From that equation, if you pick ID 0, then VGS equal 0 to get a point A. And the second one, you can pick any value for ID from 0 up to IDSS. Okay? If ID equal IDSS, ID equal 10 milliamp. Then you substitute into VGS to get VGS minus 10 times RS is 0.2. Okay, so that's why you get minus 2. So you can draw the line from here. This go here. Okay, and minus 2, you go that one. That point right here will be B. And now you tie A and B. Okay, they cut right here. So you can get ID equal 5 milliamp and VGS equal minus 1 volt.
Okay, so Mr. Pham, then the circuit is really operating at 5 milliamps and a negative 1 volt. Is that correct?
Correct.
All right.
There's only one way. You must be following. Don't ask me why. They need to draw the line. Wherever they cut the curve, from that is a Q point. And that Q point, you're able to get the ID and the VGS. However, later on you can see, if you're reading on the textbook, they not show you. Most of the textbook, they using more simple way. Then we will do it later. Now, let's see. Can you do on this one here? Telling me what the V ID you get by the graphic. Maybe hard for you to do. I go quickly for you, okay? The thing is basically, normally we never have to do. Remember the formula. V GS minus ID time RS. That's what we already did calculation. So the first thing you can pick from here. Okay? ID 0, VGS 0. And the second, you can pick any value from 0 up to 10 milliamp. So if I say I want ID equal 10, then now you calculate the VGS equal minus 10 times
Hey, Mr. Pham, I hate to interrupt you. Can you do, because you've been using 10, can you make ID equal 5?
That's okay. You can do it. I can get ID equal 5. So VGS minus 5. RS is 0.47. So what VGS equal?
Negative 2.35.
Okay, 2.35. Okay, so first thing you can draw here, go this way. Okay, and minus 2. That means that is 1 volt here.
Oh, Mr. Pham,
Yeah.
you
I was
got to
gonna
go
say-
down to 5. You're,
Yeah.
you're up at 10.
Oh, okay. Thank you.
Yeah, I was gonna say the same thing.
Thank you.
Go down to 5.
1, 2, 3, 4, 5. Right?
Yeah.
1, 2, 3, 4, 5. Okay, you draw the line here.
Right.
Then is a minus 2.3. Here. Okay, then you get the point right here, right?
Right.
And you draw the line here. Okay, and they cut at this point. Then you can go left and you can go down. You can get the ID and VGS. That's the key point. Okay, only thing is you need to know how to do it. Okay, that's what in your hand now. We already telling you. Okay. However, in the handout, they repeat ID equal 10. Okay. You can look into that. Now, this one, this normally happen. And you need to do it for me. Now, you get the circuitry here. They say solving DC cell bias without graphic. Why? If you're looking into the circuitry, what they gave it to you, in order you don't have to using any graphic.
It's given 1 milliampere.
Exactly. That's what they gave to you ID, right?
That's why we needed the graphic, because we didn't have ID previously.
Right, perfect. They already gave ID 1 milliamp. Okay? So now, what they want, they can calculate the VGS, VDS, VD, VG, VS. Do it for me. The thing is, you don't have to calculate an ID.
VGS is -1 volt.
What do you mean VDS?
Oh. Never mind. Scratch that.
Okay. What VG equal?
Zero.
Yeah,
Zero.
no,
I
Zero.
was just doing number 3. VGS is -1 volt.
It is 0.
Zero.
What VS?
ID times RS.
Perfect. ID time RS.
1 milliamp.
No, it's 1 volt.
1 volt.
1 volt.
Okay, ID 1 milliamp. RS equal 1K. Okay. VGS.
VG minus VS.
VG. Okay. So
-1.
-1. VD. Okay. VDD. ID. Time RD.
7.3.
Yeah, I agree with that.
Okay, 7.3. And the last one, VDS.
6.3 volts.
Shouldn't it be 8.3?
minus, let me see, minus and negative. Yeah, it should be. So that should be a negative. Yeah, it should be. Sorry, my number was off.
That means you can get the 7.3 minus 1, right?
Yes.
That is. So that's why you can see they will be very easy than bipolar. On the graphic, I just try to helping you to understand. Okay. How come one people?
Wait, I'm sorry. So if VDS is VD, which is 7.3 volts, and VS is 1 volt, isn't it 7.3 minus 1 volt?
Right.
Minus a negative, so it's going to be a
No,
positive.
no, because VGS is the -1, VS is
Come
positive.
on, come on.
Oh, yes.
VDS equal what?
Yeah, VS was
formula.
1. Yeah, sorry.
Okay, no, I'm sorry. I just wanted to make sure. I was confused there for a minute.
Okay.
VDS equal VD minus VS, not VGS. VS is 1 volt.
So the answer is 6.3, right?
Right.
Right.
That was a tough one. 50-50.
See,
I'm going to sleep well tonight.
easy one. Okay, any question about?
Yeah, Mr. Pham, you say everything is easy.
Yeah, to me, how come I get older, I still memorize? Your guy is young.
You taking that ginkgo biloba for your memory or something?
Yeah, so much experience.
What it is as we get younger, we forget. As Mr. Pham get older, he remember.
I said your guy lazy. You say normally every semester I think it's not the same. That's a different. By looking in the last semester and we try to improve for the next semester. How can we can help you to really understand in the electronic? You want to troubleshooting, that's okay. If you don't know how they working, how can we troubleshoot it? So that's why we have to go either take one or take two the same way. You must understand first. Then we can talking about how to fix the problem. When you measure somewhere, you don't know what you want. That not mean you need any measurement. But when you troubleshooting, you have to measure from a certain point to another point to see what the difference, what the voltage you want or you don't want. Okay, this is the last one for voltage divider bias. Okay, this is a voltage divider bias. Okay, you already see this circuitry in the bipolar. They using R1, R2 to get the voltage at the VG. Okay, since the gate source Johnson-Etic tremally high resistance, R1, R2 voltage divider is a practical unloaded. Voltage divider bias is more stable than either gate or the cell bias. However, same thing, they need the graphic. Now you calculate, tell me what VG you get. VG will be equal 15 volt times 100K divide 100K plus 390K.
$3.06
Perfect. VG equal 3.06. You see that? They given you the graphic. And that's why first thing, whatever you want to do, you have to get VG equal 3.06 volt. If you not get it, let me know. Okay, you get that?
Let's see. Hang on. 28.
Everyone get the VG 3.06 volt?
Yeah.
Okay. Now, when they get the graphic, same thing. You have to get 2 points to draw the line. The intersection with that line will be get the Q point. Same thing like cell buyer. Okay? So, telling me what VGS equal. VG. Correct?
Yes, sir.
Okay. Then that will be equal. VG is 3.06 minus VS will be equal ID time RD. That's what VGS. And if you want to calculate the ID, same way, you have to substitute VGS into the formula. ID equal IDSS time 1 minus VGS over VGS of square. And then both sides you get the unknown ID. They don't want to do that calculation. So that's why they need the graphic.
Hey, Mr. Pham,
Yeah.
on that, you got the 3.6 for the VGS, and then you said minus VS. So,
VS the ID time RS.
okay.
Time RS, not RD.
Yeah, that's what I was thinking.
And now we can need 2 points. Okay. On your handout, you already get that. We're doing calculation right here. VG equal 3.06. Okay. And now we get this is the equation right here. VGS equal VG minus ID times RS. And now you need 2 points. First thing they say select ID equals 0. If ID equals 0, then VGS equals VG 3.06. Okay, let's see. I get the curve here. I can calculate you right here. This will be 3.06. Okay. That's the point A. Then now you need the point B. In the point B, you set select VGS equals 0. So from this equation, okay, VG minus ID times RS equals VGS. Now you want that to be 0. So that will be telling you ID times RS equals VG. So ID equals VG divide RS. That's what you get, 3.8. Okay, so basically you get 2 points. 1 point here, A, and the point B will be right here. That value will be VG divide RS. That's what we can get right here. VG divide RS, 3.8. Then you can draw the line. They cut the curve right here. That's what you get the Q. Okay? And if you go to the right, you can get the current IDQ is 3.5 milliamp. If you want the VGS to going down, then VGSQ equals minus 1.5. So either for cell bias or voltage divider bias, you have to need the graphic.
Hey, Mr. Fantastic.
Yeah.
Once again, so like in the bipolar, is that in the bipolar? Do they call that like the load line or something like that?
No, they don't have a this thing.
No, I know that the load line is graphical too.
No, the graphical that is, yeah, they using that more easier than for the Jfet. Okay.
I guess what I was trying to do is
load line, they get the Q point.
Okay, all right, thank you.
On the load line, you can get the Q point easy.
But is this a form of the load line? I guess that's what I was asking.
Yeah.
Oh, it is a form of a load.
Same thing.
Okay, thank you. Thank you. Thank you.
However, this is a little harder.
Okay, thank you.
Okay, by the way, let's see I get any room in here. Okay, here. Now, for the NPN, that's what I'm talking about, NPN. So that stands for VCE. This stands for IC. Okay, now you can see the circuit. Plus 10 volt. RC. Okay, on the load line here, basically you can see that the current IB. So now I want to draw the load line here. Okay, that's the Q point, right? But my question is, what is the value at this point? I can say point A. What the value?
You mean like 1 milliamp or something? Oh, like 10 milliamps or something like that? Or?
Yeah, that's what I want to make sure you understand. At this point, telling me what VCE equal.
It'd be 10.
Now I ask the question. At this point A, what VCE equal?
0.
Perfect. Okay, anything on IC VCE must be 0. If VCE 0, that means this will be connected to the
Ground.
ground. So now you get a 10 volt 1K. You take 10 divide 1K, you get 10 milliamp. That's the first point. And now you need a second point B, so you can draw the line. So what does point B equal? VCE.
0.
Come on.
Oh, yeah. It's got to be more than 0. So it's got to be like.
Okay, at this point here, what ID?
0.
0.
0.
Any point on the VCE ID must be 0. So now you say V ID equals 0. What a VCE? What VCE?
10.
5.
Don't guess. Okay, now I say ID equals 0 at this point. That means no voltage drop here.
Right, so there's no voltage drop across that resistor, so it's 10 volts. He was right.
10 volt.
Good job, whoever said that.
So in order to draw the line, load line, okay, the thing is last time I saw you guys doing, but I still feel you guys not quite understand. Okay, first you want to draw the line, you need 2 points. The point on the VCE, they will be equal VCC, 10 volt. And the point on the ID, you just take 10 volt divide to RC. Then now you can draw the line. Okay? So, any question? Otherwise, See you guys next week. Okay. Good night.
Man.